Okay, guys, so we're going to make a start. So I think there's a talk going on still, which we're sort of waiting, hopefully might finish. So just to introduce what we're going to cover today. So we want to talk about some interesting security vulnerabilities. So there is such a thing as interesting security, believe it or not. So to make it more interesting, I'm going to show you some vulnerabilities in some major players that you're probably very well aware about. So you might have heard of companies like GitHub, eBay, those sorts of companies. So these are real-world bugs that hopefully, once you see them working, you might also think they're actually quite easy to exploit as well. So I'll let this guy introduce himself.
Okay. Just some notes about me. I have been working as software architect in 2004, and I have been involved as well in software security since 2001. I am the founder of HTIF open source security project, and I am currently the CEO of HTIF security company.
Thank you. And so that must mean I'm Marcus Pinto. So I've spent most of my time in application security and other types of security. I wrote a book called the Web Application Hacker's Handbook, and I currently have my own company where we do, surprisingly enough, application security. So we spend our time running training courses, running demonstrations, and performing software security assessments. Okay, so what we want to cover is these main areas. We first of all want to discuss two very different types of flaws. So what we'll call coding vulnerabilities, so code-based flaws, and then we'll talk about design flaws. We'll talk about maybe how easy it is to exploit some of these things, and then we'll discuss how you could potentially automate a solution against design flaws. Okay, so it might at first seem very, very hard to do, but later on we'll see it's actually entirely possible. Okay, so first of all, the real problem is this. So manual security testing is very expensive. It's quite error-prone as well, and if you're doing it from a black box, you don't have a very definite science to what you're doing, so you might well miss vulnerabilities. Also, as we know, no application is 100% secure, so even once we finish testing it, we don't really know how far we've got, really. Have we got a secure system? Have we reached sort of 90% security, or what do we have? And mainly because we don't know about all the vulnerabilities that there might be. So it could well be that there are types of vulnerabilities that no one's even sort of researched or discovered yet. So that's why we have things like, you've heard of bug bounties now. So every company has a bug bounty, a program where you can write in with vulnerabilities you're found in eBay or Microsoft or anywhere else. The reason for that is that even these companies, good though they are, they know that they'll still be missing vulnerabilities. Okay, so just to quickly introduce what these vulnerabilities actually are. So we categorize them into two main lists. So you're probably familiar with some of those. We've seen plenty of examples of things like SQL injection, cross-site scripting, various attacks on XML parsers, and so on and so forth. So you could think of all of those as flaws to do with syntax or coding, so rooted in technology. But if you look to the left, so those are examples where they're not rooted in technology anymore. They're very much design-based decision bugs that we've created. So they're the way our application has been set up to work. And they're really the focus of what we want to cover today, mainly because they're the hard ones. So in some ways, the technology-based ones have other types of solutions. So we've got some very good automated tools already on the internet that you can download and run that will find these kinds of bugs for you. Okay, so in practice, I've been doing penetration testing for about 15 years or so. We tend to think that about 55% of the flaws out there are design flaws. Okay, and when we look at code flaws, it turns out it's about 60%. Okay, so in total, there is a bit of an overlap, but if you were thinking that I was going to put up 45%, maybe that's a good example of the way our brains think. So our brains are naturally predisposed to thinking that what we're trying to do is secure and that it will work, and so on. So that's really a lot of the problem, really. So we can have automated tools which can potentially find a lot of these flaws for us in a sort of automated way where we don't need to configure them. So you might have heard of code analysis tools or white box tools that just sit and look at code, and they look for vulnerable APIs, and they tell you, I found an instance of a vulnerable API, and you seem to be using it, so I think I found a vulnerability. Okay, so that seems like a quite easy sort of way of finding vulnerabilities. The problem is that only finds you those 60%. It still leaves the other 55% sort of untested. So we do have currently manual processes for doing that. So we have things like bug bounties, as I said. We also have some other disciplines, really, some other ways of thinking where people just go around trying to do a bug bounty type thought process against applications. So they try to look for vulnerabilities that are maybe rare or haven't been thought about before. So they're looking for picking apart the design logic of the application. So in theory, I think finding coding vulnerabilities and stamping them out is largely a solved problem. Okay, so we could very much imagine that in the future, someone might create a brilliant tool that can find all these sort of coding-based vulnerabilities. And we might be using technologies in the future which just aren't vulnerable to all these things. So already, if you're thinking of things like SQL injection, people who come out of university now writing an application will probably write something that isn't vulnerable to SQL injection without even knowing what SQL injection is. So that's an example, and in future there'll be maybe similar sort of fates against things like XML parsing and so on. So now it's a big problem, but in future maybe everyone will be using secure libraries. But even then, we still do have bug bounties, and we still do find that if you look on, like, say, the Yahoo bug bounty list and so on, people are finding XML parsing issues that allowed you to read arbitrary files and like compromise stuff, even though there are supposedly these technologies that fix everything. Okay, but the really big problem isn't that; it's the design flaws. Okay, so what about the forgotten 55% that basically, like, we find on pretty much every test that we're looking at, really. Okay, so in terms of how you could potentially go around finding and fixing these bugs, so as I said, like, we do have this kind of separation of design flaws and code flaws. So the problem with design flaws is that only we, the designers of the program, really know what they are or what they could be. So nobody else actually knows how our application is supposed to work. Certainly a tool can't just read our minds and decide what our expected security policy is. So that's why we need some sort of custom checks, really, in order to check for our access control policies and make sure they're working correctly. Code flaws, on the other hand, you could just scan for like dangerous APIs and dangerous usage of APIs. So it could be much more straightforward. So we've got a lot of tools out there on the internet which we can make use of, which are written by so-called industry experts. They're external to the company, so they're not vulnerable to what we say confirmation bias. So they're not going to make the same mistakes that we might make if we're writing our own applications. The problem really is design flaws. You can imagine them to be automated and fixed via things like unit testing and so on. But the problem with that is that they are written by the people who are in charge of writing the flaws in the first place. So in many cases, they'll only be as good as the mindset of the guy who's creating the problem. That's a bit of a large statement, but in general, the people who are writing writing these sort of checks are likely to be affected by the same logical thought process. And certainly, if I were to ask this room how many unit tests you have for security design and access control, I think most people would agree it's fairly low, if it's any at all. Okay, so immediately to the audience then, I'd say, can you think of a vulnerability that the best tool in the world could not find and that you could find, or even your mother and your friend could find with no technical skill at all? So what kind of flaws do you think? Have you seen any flaws out there that like no automated tool could find, no matter how expensive it becomes? So maybe you've seen something similar to these sorts of things. So a URL like this would immediately get your interest, wouldn't it? So you'd look at this and say, well, hang on a minute, I seem to be somewhere inside a dashboard, I seem to be able to edit things, and I can edit any items just by changing the item ID. So I'm pretty sure that your non-technical friends and your parents and so on would look at that URL and they'd have a pretty good idea about what they could do. Okay, so it requires very, very little technical skill. But if you imagine an automated tool trying to find that vulnerability, it's going to have a really tough time because it doesn't really know what it's supposed to be looking for and what your application is supposed to do. Okay, so the best way of doing this is to give you some of those real-world examples out there. So hopefully this will give you a flavor of the types of flaws we're talking about. And then we'll talk about how we can potentially go around fixing design flaws that we didn't know we had. Okay, so that's really the challenge. And generally, we end up doing something along these lines. So we're trying to update a parameter value, maybe add or remove parameters from a request, try to find some new URLs that we're not really supposed to access. We're also going to play with context and time and state. So you might have heard of time of check to time of use vulnerabilities and race conditions. So we're going to play around with those as well. And what I'm going to do is just give you some examples from the internet. Okay, so all of these are public knowledge, and they've all been fixed. So I'm not about to tell you about some interesting way of getting something for free on eBay or anything. This was a vulnerability in AT&T. If I just go straight to this, just to explain it quickly. So that URL at the top was how you were supposed to access the registration for your new shiny iPad that you've been given. And more than that, that ICC ID number was the way in which you correlated your information with your pre-registration information. So if you'd bought an iPad, your registration details could be called up by using that URL and that ICC ID. So one enterprising tech blogger immediately realized that his ICC ID that he'd been given was awfully similar to other people's ICC IDs, and actually he could just brute force that number, and by doing so, he was able to see everyone else's ICC IDs. Okay, so immediately getting other people's ICC IDs meant that he could get their email addresses and telephone numbers and other information they had pre-registered with AT&T. And as I say, I think that's a very easy bug to find and exploit, but nevertheless, it did exist. Okay, so here's a familiar application, hopefully. So eBay. So they had this, they still have this situation, but the bug's been fixed. But when you create an item, you can create an offsite image. So you can link to an offsite image. Having created the item, then eBay doesn't want to just allow you to link to any old rubbish. It's got to be a real image. So what happens is when you create the item, eBay's server will go away, check the image, make sure it's a valid image by parsing it, and then it will return and let you carry on creating the item. So what's the obvious or potentially obvious vulnerability there? What do you think you might try and do as an attacker? Sorry? Okay, how would you code inject? Okay, so there's some dodgy stuff inside it. Yeah, so the thing is, eBay's server is going to check. So you're trying to attack the parser, maybe. Yeah, so that would be a valid thing to try and do. Any other types of things you could do? Yeah. Yeah, and that's that's ended up being what worked. So it turns out that you created the image, you linked to an image on your web server, and then as soon as you created the image, you changed the image on your web server. And in fact, the guys who changed it to a 302 redirect. So if you went to fetch the image as a normal unsuspecting user, you got given a 302 redirect back to eBay, and the 302 redirect make you bid on the item. So for a while, this was put up on the internet, and someone went to the page and obviously bid on it. Then they refreshed thinking, I don't know what's happened, and they bid on it again. And then eventually, they decided we should probably take this down because it's a bit naughty. But it shows, again, that's the time of check to time of use type vulnerability. So the time of the check is not the same as the time of the use. Okay, so maybe you can work out what happened here. Okay, so you've probably heard of Stack Overflow. So Stack Overflow was compromised by mistake. So this guy was doing what almost everyone in every company does at some stage. They wanted to get past their company's internet filters. So he thought, well, what I'll do is I'll create an SSH tunnel to serve a squid proxy on the internet, and then I'll direct my browser to use the other end of my tunnel. So that way all my traffic will be passed through the SSH tunnel, and then I'll be able to browse the internet. Okay, so he did this, and everything was working fine. It's just one site was working a bit too well, and that was Stack Overflow. So when he went to Stack Overflow, he was getting all the admin menus. So does anyone know why he might have been getting all the admin menus? Sorry? It was the HTTP headers, so what happened?
Well, I guess the squid proxy might set some specific HTTP headers to the request, and that's why the other side decided to authorize the user.
Yeah, indeed. So proxies tend to add the x-forwarded-for header, and it had added in x-forwarded-for localhost. And when Stack Overflow got the request, they thought, oh, this is a guy on the local box. So we serve up the admin menu when that happens. Okay, so GitHub. Has anyone heard of GitHub? Okay, so you're probably familiar with, I'm sure you're familiar with MVC. So it turns out that some people realized there were some interesting properties that you have in automatic binding or mass assignment situations. So the idea this guy had was, so this guy Homokov realized that when he created or modified his profile, he could add in extra parameters to that request. And he realized as long as the parameter was something that was a property of the model, then that property would be updated. So he managed to update his public key to the user ID of his public key to a different user. And he chose 4223, noticing that this was the Rails user, and he was able to take control of the Rails account. So he was able to then commit to the root and do stuff. It's a really good read, actually, if you fancy just a bit of fun. Just have a look through Homokov's posts, because they're all hilarious. Like, he tends to find all these sorts of bugs, and he's found a lot in GitHub itself. So if you think about this vulnerability, really, in this case, we're adding a new parameter rather than deleting a parameter or modifying it. So even if the parameter's not there, someone could still have a good guess and potentially invoke some different server-side functions. Okay, has anyone heard of JMX? Okay, so what do you think's wrong here? So that's an interesting one. So we're trying to stop people interacting with our resource by obviously intercepting URL pattern /star, and then HTTP method get, HTTP method post. So what do you reckon? Does it look good? Sensible? One guy's photographing it just in case. So there's actually quite a large implied problem here. So, and a lot of people do this. So we're only looking at get and post. That's the only time that our filter will be active. So if someone makes a head request to this resource, it's not going to protect the resource, is it? So there's a lot of different methods other than get and post. It could be any other HTTP method. So this was actually how Jboss recommended that you secured the JMX console. So you can read the original link here at the bottom. This is how they said you should be securing your JMX. If you think that's a one-off, have a look at Glassfish's history as well. So with Glassfish, Oracle's app container, you could supply track and trace methods to access all the admin functionality. Okay, so that's some examples of some of the flaws that we've seen out there on the internet, and you can see they've affected some pretty big players. So really, then the next thing I wanted to show you was potentially how easy it is to find these things for yourself and basically do the same stuff using just basically freeware tools. I'm going to try and show you in a suitable resolution as well. Okay, that will do. Okay, so what we have here is a sample application, which is a pretty insecure bank. So there's some stuff lost off the side. Maybe we can see it. Okay, so this guy can do a couple of things, like he can view his current accounts. So I think he has about 3 accounts. So these 3, so one ending in 446, 033, and 334. So what we want to try and do is see if we can access somebody else's account. Okay, so his account appears down here. So we have a tool which listens as a proxy on our machine, and we're going to tell it to intercept all requests that come out of our browser. So we'll make that request. Now we're intercepting the request in this tool. So this is our post request. And it's pretty easier for us, in this case, just to modify this number to a different number, and then we'll get to see somebody else's account. I've logged out. Let me try that again. Okay, so just here. So this tool, by the way, so far I'm just using freeware features of it, so you can download it later if you want to play with it. It's called Burp Suite. And it's pretty much the only tool we use to do our web app testing work. Okay, so that's the number we want to attack. What we should see is that we can indeed see the account that we just typed in. So we could actually potentially access anyone's account like this. Okay, so another thing we can do in this, which I'll show you quickly, is we have a transfer operation. So we can transfer money to different people. So let's say we want to transfer to somebody else's account. So let's pick this guy's account. Okay, so we'll transfer 200, whatever this is. Okay, and we see that it's charged us a 40 euro fee. Okay, so we're not terribly happy with that. So if we have a look at the request again, so this transfers operation. So this time we're going to try and make a transfer without paying that fee. So again, we open up Burp Suite. So we go to here, put in the same number, and this time we'll do a free transfer. Okay, we'll put in 200. Okay, we're intercepting requests. Okay, so this is the request, and so I know that there's potentially like a fee going to be applied. If I put in fee equals 0, and then forward that, now I should have a free transfer. Okay, so it's fairly easy to do in this case. Obviously, the application is horrendously vulnerable, but that's kind of the point of this demo. Okay, so we've already seen Apple, AT&T, making a very similar mistake. We've seen plenty of other bugs, like the Github one, where you could add a parameter and like a mass assignment attack. So they are quite real attacks as well. And what I had was, so I really wanted to find a way that people who weren't aware of security, who could be making these kinds of mistakes, would be able to use a piece of technology that could potentially secure them against these things, even if they hadn't thought about the problem themselves. So that's really where I started searching on the internet, and I found this man. I didn't find this man, I found his website, and then shortly later I found the man. But really it does hopefully help to find and fix vulnerabilities that we aren't aware about, and I think that's where certainly it was useful for me. But do bear in mind, there are a lot of tools out there on the internet that purport to find security vulnerabilities for you and solve world hunger at the same time. Very often, they say they find even low-hanging fruit. I'd say they find low-hanging pears. So that there are still lots of low-hanging apples out there once you've used these automated tools. So I'm talking about the big code scanning tools out there that find all these syntax-based flaws. Okay, so.
Thank you, Marcus. So now that we have heard about the design flaws and how to exploit them, we are going to analyze how we can protect against them. So let's start thinking about how developers protect their applications. As you know, basically, as developers, we use two kinds of solutions. We usually use security libraries, such as Spring Security, Java EE, and so on, that we usually use to implement some authorization or authentication, okay? And we apply some basic access control, such as URL level or method level, right? That's the most common use case. And additionally, we add some custom code to implement some business logic validations, okay, that our application can require. So even though these libraries and these features can cover a significant part of our needs, there are other specific issues. Now I'm going to talk about just 3 of them that are not easy to handle with these programming models, okay? For instance, the first one, row-level security. In that case, I am talking about the security. Imagine a table that we have in a database, for instance, order table. And we want to limit the users to only access to the rows that they are allowed, okay? In order to implement this kind of access control in a complex domain and with many tables and even with legacy databases, is not an easy task, right? And in many cases, you have to define some custom conditions in your query or use some additional work. And it's a very error-prone security. I mean, because depends on people because they are business-level checks, okay? So that's one of the most difficult things to solve manually. Additionally, the example showed by Marcus, the binding issue, it's very easy to exploit. It's just we are adding an additional parameter, and the protection also is very easy to apply, okay? Spring has features for that. The data binder class, and probably you know it. But the problem is that if you have thousands of screens, you have to define that data binder for thousand times. Okay, so it's very error-prone. It's not easy to do it properly. So it's very common to have issues in this kind of features. And finally, workflow issues. You know that security, traditional security, is based on two ideas. We have resources, URLs, methods, and so on, and we have roles, okay? The user has some roles. So we check basically if the user is allowed to access some specific resource, but it doesn't matter when, okay? So imagine that we have a workflow with 3 steps, step 1, step 2, and step 3, and sometimes the developers don't think about that. We can move from step 1 to step 3. If you know the URL, you can move directly to step 3. So that's not covered by traditional security, and we have to handle it manually. There are solutions out there, such as Spring Webflow, to manage these kind of things. But the same, it's very error-prone, and it's not easy to manage, okay? So if you try to implement that security by your own, that we should try to do our best, it's not easy to do it well, okay? Mainly when you have a huge or big teams developing, it's not easy to do it properly. Okay, as a consequence of that situation, we consider that this model, this traditional model, it doesn't work in practice, okay? There are different security statistics. We have seen some examples explained by Marcus previously, and even our experience mainly Marcus' experience in pen testing, we know that it doesn't work in practice. I mean, the traditional model that we use to develop applications usually generate insecure applications, okay? So we think that we should do something about it and improve that situation. Okay, and the question is why? We think, analyzing the situation, we think that one of the reasons of that situation is that existing programming models offered by Java, .NET, PHP, and so on starts with an open application that we must secure manually, okay, using libraries, using custom code. But the security model is that we start everything open and we have to close it manually, okay? So basically, thanks to that model, there is a huge responsibility on people, okay? And it means that we are open to human error, okay? That's one of the most important reasons of that situations. So we think that we have tried to automate those things and try to do at least some of the verifications in another way, okay? So even we know that it's impossible to automate 100%. We know it, it's impossible to do it, of course. But we think that if we are able at least to automate a part of that protection of design flows, because regarding security bugs or code syntax flows, we know how to fix them. I mean, we have tools to do that. But regarding design flows, we don't have a tool for that, okay? We have people. And it requires time, and it's very error-prone. So we think that we need something to automate that. Thinking about how to automate that, it's interesting to see the anatomy of design flow attacks, okay? We consider that basically there are 2 kinds of design flow attack. Contract manipulation attacks, when the end users change the contract offered by the server. Basically, they change a URL, add an additional parameter, change the value of a parameter. They are changing basically the interaction contract offered by the server, okay? That's some of the most used attack techniques in design flows. And secondly, there is another one that we call contract abuse attacks, where the client is not breaking the contract. I mean, it's respecting the interaction contract offered by the server, but anyway, they are able to implement some attack, okay? Let's see an example to understand the idea. In that screen, the green areas represents the part where the server side is showing us some options that we can select, okay? We can choose, but we shouldn't update, okay? We shouldn't change those values. We shouldn't change the value of the URL. We shouldn't change the values of a select field, okay? So if we perform any change on those green areas, we consider that it's a contract-based attack, okay? Where we are changing the contract offered by the server side. On the other hand, the red area, the text field, the open text field, we can write whatever we want, okay? By default, we can write whatever we want because the server is allowing us to type anything, okay? So using that text field, we can try to perform an attack, right? In that case, it's the kind of contract abuse attack where we are trying to do something illegal, but using the contract offered by the server, okay? So it's important to think about it. And if we have eliminated all the security bugs before, imagine that you don't have any SQL injection, cross-site scripting, and so on. You have reviewed your login, and you have a session management, a good session management, probably based in the application server. If you try to attack an application without breaking the contract, it's very hard to make an attack, okay? Try to implement an attack with a text field without any security bug in the server side, okay? It's not easy. It could work in some cases, but it's not easy to perform an attack like that, okay? So it's important to take into account that perspective. So even we know that it's very difficult to automate everything, we think that we can automate the part of contract-based attacks, and we can apply a contract-based protection, okay, to protect against these kind of attacks. So how do we implement this? Well, the first step is that the server must define what is allowed. That's the first rule, okay? The server must register what they are publishing to the client, okay? And afterwards, check if the client has break the contract, okay? We have to verify. We have to verify that and reject the request that break that contract. For instance, imagine that someone changed a URL, is breaking the contract. We are going to reject that request, okay? So in order to implement that, I have been working in that area since 2008, and we started a project that is HDIF project. So we have been working in that field many years ago. We have used that idea in production in many applications. So now we are going to explain how we do that, okay? So basically, HDIF is based of 2 components. First of all, we have an extension of some of the most used technologies to develop web application or REST APIs, such as Spring MVC, Struts, JSF, or REST APIs such as Spring REST or JAX-RS. And with this extension of these libraries, and without changing the programming model offered by those libraries, we are able to extract the contract that we are offering to the clients, okay? That's the first step that we do. I mean, when we send a response to the clients, we are able to infer, to extract that contract and use it afterwards by other component that it's a web filter, okay? That implements a validation using the information that we have read previously, okay? So the architecture is based on the extension of the existing programming models that probably most of you are using in Spring ecosystem. And thanks to a declarative installation, installing a library and some configuration files, we are able to infer that contract and to apply contract-based protection against different requests, okay? So now we are going to see the same demo, but in that case with HDIF. Please, Marcus.
Okay, so as well as the insecure bank, we have a secure bank. So this one should be the secure one. So what I'm going to do is exactly the same as I just did. So I'm going to try and maybe get a free transfer by putting that fee to 0. And you should see the effects of like having this, this technology layered on top. Okay, so we go to transfers, make a transfer. Okay. And we'll put in okay, so this time we'll let me just change this resolution. This is impossible to use, this resolution. Hang on. All right. Okay. So as before, we're going to intercept the request, and then we're going to try and add in that parameter. Okay, so if you remember last time, we just added in fee equals 0. So you can see the other thing we've got here is this hdiv state. Okay, so that's the indicator that we're looking at a different application. Let's just spell that right as well to make it fair. Okay, and we can see the results of having hdiv there as well. So I think if I do the same with one of these accounts, maybe try to view somebody else's account, you should see the same effect as well. Okay, so we'll hit go. And we've got the same thing as before.
Following the demo, the Marcus demo, now we are going to theoretically review the real examples that we have reviewed in the beginning. So thinking about how it will be work with a contract-based protection, okay? To review if with this automated approach we will improve or not, okay? In the first case, the eBay case, in that case, the vulnerability was based in some change in that theoretical image, okay? So depending the attack, using a contract-based approach, we can protect against this risk. In the specific case of if we implement a redirect request to implement an accidentally or an indirect redirect from the client, in that case, using a contract-based approach, it doesn't work, okay? Because we control all the URLs from the server side. We add some aleatory token to each URL, so it wouldn't work, okay? In some other exploits, it couldn't work. It could work. In the Apple case, it was a parameter tampering attack. That is an example that we have seen. So in that case, using a contract-based approach is not possible, so we will be protected. In the Stack Overflow case, it's based on an extra header in the request. In that case, a header, we can consider that it's a contract at server side. A header is something that the client can include, okay? So in that case, a contract-based approach doesn't work. In the case of Stack Overflow case, it was a binding attack where the client sent an additional parameter. So in that case, using a contract-based approach, we control which are the fields that we are exposing to the client, so we will avoid the risk. And finally, the Jboss issue, in that case, was based on accidentally exposed HTTP method. When we use a contract-based approach, in our case at least, by default, when we expose a URL, when we expose a REST service, everything is get by default, okay? So if you want to change that behavior, you have to publish in a explicit way which are the methods that you want to expose, okay? So we can avoid this indirect way to publish things, okay? So as you can see, we cannot solve everything, but we can solve a significant part of the issues, okay?
Okay, so that's hopefully shown you some of the interesting bugs and also some of the limitations of this sort of approach. Firstly, you could imagine maybe any of these categories being particularly difficult challenges for any approach, really. So if data is, if there's an explicitly editable field, there's only so much that we can do to try and impose that implicit contract-based security on the application and on the clients, obviously. So also, wherever input was non-standard in its location, something like an extra header, again, that's quite challenging for it to defend against. And the other obvious one is just the abuse of like the legal contract. So abuse of policy. If there's no password lockout or no password complexity or that sort of bug, again, there's nothing that the any software can really do. You just have to implement it. And finally, these sort of time and state-based vulnerabilities, like the time of check to time of use and race conditions and so on. Again, it's not really something that can be solved in this kind of way. That said, though, for the maybe like 80-90% of the vast majority of typical vulnerabilities that we see, so the typical access control flaws where there's some parameter tampering, this is potentially a way of solving those bugs, even bugs that we haven't yet thought about. Okay, so I think there's probably not time to run through any more demonstrations. So we'll probably save some time for a summary and then take some questions as well. So what we'd say really is if you're starting out on security or continuing an existing project, we'd recommend using an application security testing tool to try and detect security bugs. So the code-based ones like SQL injection, cross-site scripting, XML attacks, and so on. So they'll find the 55, and that sort of gets them out the way in terms of verification. Then you have that other 60% that you still need to fix. So the design level flaws. Again, this will get you quite a long way through maybe fixing the vast majority of those, depending on your particular software. And finally, so there will always be bugs left over. This software isn't designed to stop people like me doing our professional jobs necessarily, just to slow us down and make it harder and only leave the very weird category of bugs left over. So hopefully by the time something like an HDiv type solution is deployed and you've gone through all your code-based bugs with an automated tool, you're only left with a few edge cases really. So maybe like eBay and those sorts of companies, you can have a bug bounty program or pen testing to just find those extra few bugs. So I think that's probably a good time. We've just hit about 5 minutes left, so we'll take any questions. I don't know who the questions are going to be directed at yet. Does anyone have any questions, of course? That's the other question. So everyone's going to run away and implement this? Or everyone's going to run away and hack stuff? Or both?
Sorry, why the macro?
So you previously mentioned Burp Suite for starting manipulating some requests. I know, for example, a SQL map is another tool for SQL injections.
Mm-hmm.
Are there any other general tools you would recommend, especially for the developer and not really for the security expert?
Sure. Okay, so immediately my conflict of interest is the book I wrote, the Web Application Hacker's Handbook, was written by me and the author of Burp Suite. So I do know the guy pretty well. That said, if you look at anyone talking about AppSec, they all use Burp Suite. All the features of Burp Suite that I used just now, they're all like freeware features, so you can download it for free, and there are other tools that intercept traffic. And pretty much we don't use much else other than Burp Suite, and we write some Java extensions for it when we need to. So there are tools like SQL Map that exploit very specific problems, but to find the bugs, you can use these tools. In terms of automating finding like code-based flaws, so scanning, like black box scanning and code scanning, unfortunately the best tools are paid, so there's no real way around that. If you want something free, there's something called Find Security Bugs, which is like an IDE plugin, which is fairly reasonable. And SAM8 did a list of, that's SAM8, S-A-M-A-T-E, did a list of freeware tools as well, and as well as paid tools. But I don't know how good the list is these days. I don't know if that answers your question. Okay, cool. I mean, I'd recommend, if you haven't looked at Burp Suite and you find security interesting, get a copy of Burp Suite for free. It's on portswigger.net website. And just have a play around, because it is a bit of an eye-opener. It's a bit like Fiddler, the way it works, but you'll immediately see the additional features that are useful for an attacker. Okay, All right. Well, if that's no more questions, I think we'll leave it there. Okay. Thank you very much.